This video will demonstrate how to solve gas law problems once the equation has been chosen. To review, these are the gas law equations which were used in the last video. Solving word problems. Remember that the variable must be determined first. This will guide you to which formula you're going to use. Pressure is going to be measured in atmospheres, kilopascals, millimeters of mercury. Volume will be measured in liters. Temperature in Kelvin, and number of moles the variable will be in. If we're given milliliters, you can change those over to liters by dividing by 1,000. If you're given degrees Celsius, if you add 273, that'll give you Kelvin. Here is the first question that we had, the first problem. We looked at all the data, gathered it out of the equation itself, out of the problem itself, looked at the equations, decided which one we're going to use. Decided it was going to be Charles's law, so we wrote it down. This is where you should be at this point on your notes. Once the equation is chosen, you need to multiply both sides by T2 in order to isolate the V2 on one side of the equation by itself. Notice that T2's on the right cancel out, and so your resultant equation is T2 times V1 divided by T1 is equal to V2. Plug in your values, temperature 2, volume 1, and then T1. Go ahead and do the math at this, and you'd have 348 times 2.32, get an answer for that, and then divide that by 313. The units that will cancel out here are Kelvin, and your result is going to be 2.58 liters. For problem number 2, we looked at the equation again, decided it's Boyle's law, wrote down Boyle's law in our problem, so this is where you should be. Once you do that, what we're going to do is we're going to have to divide both sides by P2 in order to isolate P2 on one side by itself. Notice here the P2's on the right side cancel, and your result is going to be P1 times V1 divided by P2 to give you V2. Easy part now, plug in your values, P1, V1, and P2. Okay. Look at your units. The units that will cancel out here are atmospheres. Do the math. 1 times 14 divided by 1.54 gives you a result of 9.09 liters. Problem number 3. Once again, this is where we gathered the data last time. Looked at our equation. We decided it's going to be Dalton's law. Wrote down our equation. We're going to rearrange the equation so that our unknown is on one side of the equation by itself. So we're looking for the pressure of hydrogen here. So to get that, we take the total pressure minus the pressure of the helium. Remember, what you do to one side of the equation, you have to do to the other. Plug in our values. And then simply subtract here. Notice none of the units cancel out, so we end up with 161 millimeters of mercury. Problem number 4. Looked at our equation, decided it was going to be Avogadro's law. Once we get there, what we need to do is go ahead and write it down. And we're looking for V1, so that means we need to multiply both sides by N1. Multiply the left and multiply the right. Notice the N1's cancel out, so our resulting equation is V1 is equal to V2 times N1 divided by N2. Plug in our values. So this is 22.4 liters times 2.4 moles divided by 1 mole. Notice the units cancel out here are the moles, and the units we're left with are liters. Our answer is 53.8 liters. Question number 5. We gathered all our data. Looked at the equation menu. Decided it's going to be the ideal gas law. And then went ahead and wrote it down. Now here, once we wrote it down, what we need to find by itself is number of moles, N. So in order to get N all by itself, what we need to do is divide both sides by RT. Divide the right side by RT and divide the left side by RT. Notice that R's cancel, T's cancel. So our resulting equation is PV divided by RT. Plug in our values. There's my pressure and my volume. The R constant, in this case we're going to use 0.0821 because of the units of our pressure. Notice the atmosphere units for pressure match the atmosphere units for the R constant. And then times the temperature in Kelvin. What we have here, we have the atmospheres will cancel. You have atmospheres on top, atmospheres on the bottom. And then the Kelvin will cancel. And then the liters will cancel. So the only units we have are moles. Once you do the math here, what you're going to do is you're going to take 3.81 times 0.044, get an answer for that. And then in parentheses, 0.08214 times 298, get an answer for that. Then it becomes top divided by the bottom. Okay. As a summary, when doing calculations, solve the word problem, write down the given and your unknown. Use the given, find the correct equation, which has all the variables that you're looking for and the unknown. And then finally, use the equation to solve your unknown. If you will write down your givens and what you're looking for, it makes it real easy. It's just find the equation and then plug in your values as you need.